Monitoring this screen. Can you hear me? Evening, afternoon. How's the stream today? It looks incredibly bad. I don't know. I tried modifying some settings. I don't know if it will result in anything, but I tried. Yes, it seems pretty bad. I'm trying to monitor it, and it seems pretty bad. Oh, thank you. Thank you. I'm glad you like it. I thought I liked the wings. It's really sparkly. Yes, the chat, I changed the design of the chat. I mean, it was just a mini setting. Yeah. So, welcome to this little corner of the internet. The stream is really bad, isn't it? Like last time, each time I'm back, my character just goes away, so that's a little bit not nice. I should be back? Yes. But I should be back right now. You should be able to hear me. Right. Okay, I think we're back. And yes, I am still streaming, question mark. Yes, it says live on Twitch and also YouTube. Yes, also YouTube. Okay, the YouTube one I wasn't sure about. When I'm not a talking head, I mean, I'm just a sound, not a head talking, it's a bit hard for you guys to focus, so that I can relate to. So that's why I should share my screen. And I'm gonna fix my character in a bit. The internet change messed with it. Okay, so let's do the recap while I don't have a face. Oh god, what is this? Oh, wrong. Did they change the whole... No way. No, this is not it. Isn't it /? Oh, there it is. Okay. Got it. That messed with me. Yes. So what are we doing here? What is the reason of our existence? Well, that I can't tell you, but what we're doing here during this live is we're studying this course from fast.ai called Introduction to Machine Learning for Coders, and it is taught by Jeremy Howard on the fast.ai platform, as I just said. And my face is back. What's up? Yes, we've been doing this for a while. This is the 26th stream, so yes. How's the buffering doing? Is it a tiny bit better, or is it still the worst? Okay, I can't tell. Okay. We are currently in lesson 8, which is about gradient descent and logistic regression. We are, I think this is like the 3rd stream that I am doing on lesson 8. So there's that. Yes. if all goes well, let's try and finish it today, even though that doesn't mean I'll be done with the lesson, because I haven't gone through... actually, I had an error when I tried to go through this Kaggle notebook. Yep. Okay, I think the buffering should be a smidge better. Hopefully. Thank you. Yes, it's become a game of peekaboo. I'm having like, it's messing with me. I made the chat come from the top instead of the bottom, and now I keep looking at the bottom. I'm like, where's the new chat? But it's at the top. Yeah, okay, it's at the top there. Anyway, yes, I am sharing the screen. Thank you for... yes, me. So yeah, we were looking at this, what was it called? How we calculate error in the gradient descending, right? The logs and all of that. And then he said, let's do the one-hot encoding and calculate it that way. And as you see, no, I don't see. Okay, these are different errors because it's for different things. Anyway, I'm gonna play this and see where we are.
Entropy is forth for each one, right? And so add them all up. So categorical cross entropy is identical to binary cross entropy. We just have to add it up across all of the categories, right? So try and turn the binary cross entropy function in Python into a categorical cross entropy. In our PyTorch, we had 10 as the output dimensionality for this matrix, because when we multiply by a matrix with 10 columns, we're going to end up with something of length 10, which is what we want. We want to have 10 predictions. Okay? So that's the loss function that we're using.
Oh.
All right, so then we can fit the model. And what it does is it goes through every image this many times. So in this case, it's just looking at every image once and going to slightly update the values in that weight matrix based on those gradients. And so once we've trained it, we can then say predict using this model on the validation set. Right? And now that spits out something of 10,000 by 10. Can somebody tell me, why is this of shape, these predictions, why are they of shape 10,000 by 10?
The 10 is what we chose, but the 10,000 I can't say.
Go for it, Chris, it's right next to you.
Well, it's because we have 10,000 images we're training on.
10,000 images training on, so that's what...
Oh, shoot, you're right. I read that somewhere.
Well, we're validating on in this case, but same thing. So 10,000 we're validating on, so that's the first axis.
Yeah, that's the first axis. And then the second axis is because we actually make 10 predictions per image.
Good, exactly. So each one of these rows is the probabilities that it's a 0, that it's a 1, that it's a 2, that it's a 3, and so forth. Okay, very good. So in math, there's a really common operation we do called argmax. And when I say it's common, it's funny. Like, at high school, I never saw argmax. First year undergrad, I never saw argmax.
Yep,
but somehow after university, everything's about argmax. So it's one of these things that's for some reason not really taught at school, but it actually turns out to be super critical. And so argmax is both something that you'll see in math, and it's just written out in full, argmax. Mm-hmm. It's in NumPy, it's in PyTorch, it's super important. And what it does is it says, let's take this array of preds, right, and let's figure out on this axis, remember axis 1 is columns, right, mm-hmm. So across, as Chris said, the 10 predictions for each one, for each row. Let's find which prediction has the highest value and return, not that, if it just said max, it would return the value. Argmax returns the index of the value. Right? So by...
Okay. Is that all that argmax does? give me the index of the max value? Or am I just not letting him finish and talking over him when I should have let him finish talking?
By saying argmax axis equals 1, it's going to return the index, which is actually the number itself, right? So let's grab the first 5. Okay, so for the first one, it thinks it's a 3, then it thinks the next one's an 8, next one's a 6, the next one's a 9, next one's a 6 again. Okay, so that's how we can convert our probabilities back into predictions. All right, so if we save that away, call it preds, we can then say, okay, when does preds equal the ground truth, right? So that's going to return, so there's our 91.8%. And so you want to be able to like replicate the numbers you see, and here it is. There's our 91.8%. Right? So when we train this, it tells us, the last thing it tells us is whatever metric we asked for, and we asked for accuracy. Okay, so the last thing it tells us is our metric, which is accuracy, and then before that we get the training set loss, and the loss is again whatever else we asked for, negative log likelihood, and the second thing is the validation set loss.
Negative something likelihood loss, less likelihood something. This is what we looked at yesterday. Got it.
PyTorch doesn't use the word loss, they use the word criterion. So you'll see here crit. Okay, so that's criterion equals loss. This is what loss function do we want to use. They call that the criterion. Same thing. Okay?
Okay.
So here's how we can recreate that accuracy. So now we can go ahead and plot 8 of the images along with their predictions. And we've got 3, 8, 6, 9. Oh, wrong.
Oh, would you look at that? Oh, that's a 4 and it thought it's a 9. And I suppose this 3 does look like a 5.
5, wrong. Okay, and you can see like why they're wrong. Like this is pretty close to a 9. It's just missing a little cross at the top. This is pretty close to a 5. It's got a little bit of the extra here, right? So we've made a start. And all we've done so far is we haven't actually created a deep neural net. We've actually got only one layer. So what we've actually done is we've created a logistic regression. Okay, so a logistic regression is literally what we just built. And you could try and...
Okay, I'm going to listen really, really seriously so that I can explain what logistic regression is.
Replicate this with sklearn's logistic regression package. When I did it, I got similar accuracy, but this version ran much faster.
Looks like a 4 to you. Well, that's because I don't want to say it, but you made me say it. That's because you have bad handwriting. You can recognize people's bad handwriting.
Because this is running on the GPU. But this version, we can, implement it very quickly with PyTorch. Can you pass that to Ian?
So when we're creating our net, we have to do .CUDA. What would be the consequence of not doing that? Would it just not run?
It wouldn't run quickly. Yeah. It'll run on the CPU. Can you pass it to Jade?
Okay, we chose GPU. Yep. With the CUDA
So
thing.
when we build the neural network, why is that we have to do linear and followed by a nonlinear?
The details of why the universal approximation theorem works. Another version of the short answer is that's the definition of a neural network. We'll go into a lot more detail of this in the deep learning course. But for this purpose, it's enough to know that it works. So far, of course, we haven't actually built a deep neural net at all. We've just built a logistic regression. And so at this point, if you think about it, all we're doing is we're taking every input pixel and multiplying it by a weight for each possible outcome, right? So we're basically saying, on average, the number 1, has these pixels turned on, the number 2 has these pixels turned on. And that's why it's not terribly accurate, right? That's not how digit recognition works in real life, but that's all we've built so far. Okay, can you pass that to Devin?
So you keep saying this universal approximation theorem.
Yeah.
Did you define that?
But let's cover it again because it's worth talking about. So, all right. So Michael Nielsen has this great website called Neural Networks and Deep Learning, and his chapter 4 is actually kind of famous now. And in it, he does this walkthrough of basically showing that a neural network can approximate any other function to arbitrarily close accuracy.
I think he talked about, isn't it the second time he's talking about this book? I think.
As long as it's big enough. And we walk through this in a lot of detail in the deep learning course. But the basic trick is that he shows that with a few different numbers, you can basically kind of cause these things to kind of create little boxes. You can move the boxes up and down. You can move them around. You can join them together to eventually basically create like connections of towers, which you can like use to approximate any kind of surface, right?
Whoa. That looks pretty cool.
So that's basically the trick. And so all we need to do, given that, is to kind of find the parameters for each of the linear functions in that neural network. So to find the weights in each of the matrices. And so far, we've got just one matrix, and so we've just built a simple logistic regression so far. Kunal, did you have a question? No.
Just a small doubt. I just want to confirm that when you showed images of the examples of the images which were misclassified, they look rectangular. So it's just that while rendering, the pixels are being scaled differently. So are they still 28 by 28 square?
They're 28 by 28. I think they're square. I think they just look rectangular because they've got titles on the top. I'm not sure.
Actually, they sort of look rectangular because the numbers are like that. I don't know. That's a funny point.
Oh, good question. I don't know. Anyway, they are square. And like Matplotlib, does often fiddle around with, what it considers black versus white and, having different size axes and stuff. So you do have to be a bit careful there sometimes. Okay, so hopefully this will now make more sense, because what we're going to do is like dig in a layer deeper and define logistic regression without using nn.sequential, without using nn.linear, without using nn.log softmax. So
we're going to write it ourselves? That's going to be cool.
We're going to do nearly all of the layer definition from scratch. Okay. So to do that, we're going to have to define a PyTorch module. A PyTorch module is basically either a neural net or a layer in a neural net, which is actually kind of a powerful concept of itself. Basically, anything that can kind of behave like a neural net can itself be part of another neural net. And so this is like how we can construct.
Anything that can behave like a neural net can be a part of a neural net. Okay. I don't know. There are times where I'm like, I don't understand anything he's saying. Let's see where we go from here. I mean, I got that sentence. I'm just saying, I get lost a lot.
Particularly powerful architectures combining lots of other pieces. So to create a PyTorch module, just create a Python class, but it has to inherit from nn.module. So we haven't done inheritance before.
Inheritance comes within the parentheses? That's funny. Wait, we inherit like this? Okay. Isn't that how parameters supposed to pass? Or is it like the self? Nah. Oh, it's a class. Got it. For classes, I suppose it works that way. Okay.
Other than that, this is all the same concepts we've seen in OO already. Basically, if you put something in parentheses here, what it means is that our class gets all of the functionality of this class for free. It's called subclassing it. So we're going to get all of the capabilities of a neural network module that the
Without a dime, for free.
PyTorch authors have provided, and then we're going to add additional functionality to it. When you create a subclass, there is one key thing you need to remember to do, which is when you initialize your class, you have to first of all initialize the superclass. Right? So the superclass is the nn.module. So the nn.module has to be built.
Oh my god.
Before you can start adding.
Underscore just rated with 24 viewers.
No way. Oh my god, thank you. What? Hi. Thank you, do who. Oh my god, this is so cool. I'm scared now. Hi. Hello, wow. Hi people. Thank you. Thank you. I'm lost for words. What were you guys doing before this raid? What? My god, this is like the biggest raid I've gotten. Oh my god, I honestly did not expect it. Thank you so much. Enlin and Frogbottom. Whoa. Thank you. No, I'm just scared of people in general. Game dev, cool. Wow. That's amazing. We are cozy writers. That's I went away to YouTube, and then when simulcasting was allowed, I was like, I really miss Twitch because it has so many cool things like rating and all of that. So yeah, the community in Twitch is a bit unmatched. Software devs and VTubers. What? that's like the exact Venn diagram that I'm in. I'm actually studying this this thing here, neural networks. Yes. I was thinking I haven't seen you before. I've technically been on Twitch since 2021, but I barely stream because I'm lazy. But I've been streaming very constantly for like a month and a half, and now this is my second stream coming back to Twitch, simulcasting. So yes, oh thank you, Ellen. That's really, I really appreciate
underscore
it.
just followed. CL welcomes you.
Yes, I welcome you. Thank you so much. Oh my god. Thank you.
Do underscore just followed. CL
WB to
welcomes
Twitch?
you.
What does that mean? Is that supposed to be welcome? Or yeah. Introduction to Machine Learning for Coders. I applied to PhD program. There we go. I'm forgetting to talk because there are a lot of people here. Oh god, thank you. Hello Mr. Frog.
Bottom just followed. CL welcomes you.
Wow. Whoa, this is now becoming very thank you. I appreciate this. Twitch is, welcoming me back. I did not really expect this. Yeah. So I'm because I have a background in software engineering and not anything in AI, I'm, scared as usual. So I'm thinking this will help me. Thank you, Mustafa. Yeah, see, Mustafa, Twitch has a really nice community. And Mustafa is chatting from YouTube. Yes. And yeah, the plan is to take this course and take as many other courses that I feel like I need, because imposter syndrome is real. And yes, continuous learning is a cool thing. I do like continuous learning. And what we're doing here, he did the logistic regression, like using already existing, methods, and then he's going to write it himself. So that part was pretty cool. So I'm gonna go back just to show you guys a bit. Just a bit, like where we see the result, I suppose. Yes, neural networks for logistic regression in PyTorch. And then after that, he was everyone I have met in software devs VTuber community has been really sweet. That's true. I have made like a few friends, so now I can say I've made a bit more. I will definitely check. I always have a really hard time clicking people's channel and going into their channel. How do I do that? 'Cause like, is that it? Channel. Oh, there. That did it. Okay. Oh god. Each time.
Yuki Viti just followed.
Thank you.
CL
Yuki
welcomes you.
Okay, I'm definitely going to check out you guys' channel. Oh my god, you even have wings, and I have wings. What? I mean, the wing is oh, by the way, this is MNIST, using PyTorch, and there are some mistakes, like this 4, it thinks it's a 9, this 3, it thinks it's a 5. The prediction was 91%. Yeah, so I'm gonna play it so that we hear him talk, but if anyone wants to say anything, I will happily do my best to answer you. And thank you again so much for coming by. If you feel like leaving, do whatever is best for you.
Okay, so hopefully this will now make more sense, because what we're going to do is like dig in a layer deeper and define logistic regression without using nn.sequential, without using nn.linear, without using nn.log softmax. So we're going to do nearly all of the layer definition from scratch.
Mm-hmm.
Okay, so to do that, we're going to have to define a PyTorch module. A PyTorch module is basically either a neural net or a layer in a neural net.
Okay. For now, we're doing logistic regression, and I think we're just doing one layer, aren't we?
Which is actually kind of a powerful concept of itself. Basically, anything that can kind of behave like a neural net can itself be part of another neural net. And so this is like how we can...
Yes. Interesting, and like 50% of the time I understand what he's saying, and the other 50% of the time I'm like, it's going over my head.
Construct particularly powerful architectures combining lots of other pieces. So to create a PyTorch module, just create a Python class, but it has to inherit from nn.module. So we haven't done inheritance before. Other than that, this is all the same concepts we've seen in OO already. Basically, if you put something in parentheses here, what it means is that our class gets all of the functionality of this class for free. It's called subclassing it. So we're going to get all of the capabilities of a neural network module that the PyTorch author...
Part reminds me of Java, because here we're using Python.
There is one key thing you need to remember to do, which is when you initialize your class, you have to first of all initialize the superclass. Right? So the superclass is the nn.module. So the nn.module has to be built before you can start adding your pieces to it. And so this is just like something you can copy and paste into every one of your modules. You just say super.init,
Basically, give me what's already there, and then here's what I'll add to it. For inheritance, right?
This just means construct the superclass first. Okay? So, having done that, we can now go ahead and define our weights and our bias. So our weights is the weight matrix. It's the actual matrix that we're going to multiply our data by. And as we discussed, it's going to have 28 times 28 rows.
Which is the size of images in MNIST. Yes. What exactly are the weights? Do we... Oh, shoot. It's just a function, right? So we have to... Are we creating this function, or is it already there?
And 10 columns. And that's because if we take an image which we flattened out into a 28 by 28 length vector, right, then we can multiply it by this weight matrix to get back out a length 10 vector, which we can then use to consider as a set of predictions.
Okay, so yeah, basically 3 is a 3, should not be considered others. You know, the one hot encoding we did last time. But what about the weights?
So that's our weight matrix. Now, the problem is that we don't just want y equals ax, we want y equals ax plus b. So the plus b in neural nets is called...
Oh, y equals ax. A is the weight, right? Okay, we have a double... okay. I am very, very much lost, but let's see.
Called bias. And so as well as defining weights, we're also going to find bias. And so since this thing is going to spit out for every image something of length 10, that means that we need to create a vector of length 10 to be our biases. In other words, for everything 0, 1, 2, 3 up to 9, we're going to have a different plus b that would be adding.
Okay, so my brain might work. The b, ax plus b is what we're using. The a is the weight. The b is the bias. Question mark?
Right? So we've got our data matrix here, which is of length 10,000 by 28 times 28.
We have 10,000 digit images of handwritten digits that are 28 by 28. Okay, this part I'm with you. Go ahead.
Okay. And then we've got our weight matrix.
Neural network stuff is really cool. I'm a smooth brain dragon, though I struggle with complex things. I don't think I've described myself as a dragon, but the smooth brain, I think I have. Yeah, it's pretty complex, especially like, I mean, it's I'm guessing like anyone who's interested in neural networks has seen the 3 brown 1 blue video about it, which explains it pretty well, like concept wise, in an abstract manner. Okay, I get it. How do I implement it? I can't get there, you know? And if anyone hasn't seen that video I'm talking about, I can put it in the chat. 3 brown, 1 blue neural network. See, it's shoot. That was scary. Oh yeah, it's a whole thing. The what's neural network, but you know, first video. I can share that. It is very... See, it's even talking about the MNIST thing. It's a really, really interesting video that I have not watched for a few years, you know? So if I paste it here, it should go to Twitch and YouTube at the same time. Why didn't I copy it? Yes, same. It's not pasting on in remaster, but hey, that's cool. we're doing it twice. Done. Yeah. So I'm guessing like a lot of us have seen. Okay. Sorry. I saw myself pasting it in the chat twice. Up there. Yeah. I just feel really not confident, especially like going back to school and seeing younger people doing. I mean, great, good for them, more power to them. It's just, yes. And I've never used anything like a Hugging Face or Hugging Face is actually mostly natural language processing. It's a place that lets you build, train, deploy models. I suppose it could be close to Kaggle, but yeah. So that's a thing that I would like to use. I mean, obviously, you can do everything on your computer, but that's no longer, everything is getting bigger and bigger and bigger. Yeah, so that one's scaring me as well. Today we are letting our fears be out in the sun. Yeah, so I'm like, I'll start here and then use this as a, jumping pad, I suppose, to learn new things, other things. What is the time? Okay, I have like 20 more minutes.
Which is 28 by 28 rows by 10. So if we add on...
This is the wait. Okay.
Our bias.
Plus bias.
Sorry, wrong way around. Add on our bias. Okay, like so. And so when we add on, and we're going to learn a lot more about this later, but when we add on a vector like this, it basically is going to get added to every row.
Yep. I vaguely remember summing up matrices.
Basically just creates some normally distributed random numbers. So torch.randn returns a tensor filled with random numbers from a normal distribution.
Oh.
We have to be a bit careful though.
There it is.
When we do deep learning, like
I said, I don't know where getWeights is coming from. It's just random numbers. Okay. It's a function that we define ourselves, and we're just getting random numbers. Oh my god!
Good Toro just followed.
Thank you.
L welcomes you.
And also, I had a follower goal of 75, and now it has been achieved. Yeah, I think that's for that, right? Yeah, see?
We reached our followers goal of 75.
Aww.
Thank you, everyone.
Thank you, everyone. That's so cool. Wow. Okay. I'm feeling quite welcomed. That's nice. Thanks, everyone. Now I'm compelled to add another follower goal. We'll do in due time. Let's not get ahead of ourselves.
when we add more.
Oh, do more. Literally, like, get better resources. Give me more. Wow. Thank you. Thank you. What do you go by? Who? Like, do you go by a name? Because, like, my character goes by CL. Thank you. People are so nice. I'm really motivated. I read a paper yesterday and I was like, oh, that's enough for today. Now you guys are motivating me to do better. Yeah. Like, I have this really unhealthy mentality of I did something good. I should do better now. Better and better and better until, I had this, what is it called? An ID on a website called Death by Learning. Because I was like, yeah, basically that's what I'm doing. Doesn't mean I'm smart, honestly. It just means I like learning. Okay. Cute name. It makes you happy when you read it.
We have a matrix which on average tends to increase the size of the inputs we give to it. If we
matrix that what? Yeah, 3 brown, 1 blue is great. It helped me implement one myself from scratch. Oh my god, that's so cool. No way. You are where I need to be. Tell me your ways. How did you do this? That's cool. You have a really adorable character. That's so cute. Oh, it's a cat. Who doesn't love cats? I love cats. Okay. I'm gonna be looking out for you guys' stream. Inshallah. Big brain cat girl. Yes! Do you approve of my cat ears? Today I have cat ears. The other day
of the inputs we give to it. If we then multiply by lots of matrices of that size, it's going to make the numbers bigger and bigger and bigger.
Numbers going bigger. I see. So cute. I think I just moved to my cat voice. Sorry about that. Because we have a lot of stray cats here. Aw, thank you. We have adorable stray cats that we feed. I don't believe in house cats because, you limit their freedom. Yeah. Cats that want to stay in our house, cool. I mean, not indoors, outdoors. Yeah. And now this was the cat lesson. Continuing to neural networks.
Like exponentially bigger. Or what if it made them a bit smaller? It's going to make them smaller and smaller and smaller, exponentially smaller. So because a deep network applies lots of linear layers, if on average they result in things a bit bigger than they started with, or a bit smaller than they started with, it's going to exponentially multiply that difference.
What? Why are we surprised? I did also help them from a kind and big-brained maths person to explain. Okay. What on earth derivative with respect to meant? That's cool. Okay, so a lot of big brain people here. I like being in a place where I am, I feel like, they say a person is the average of 5 of their friends. So I like being in places that people are better than me so that I can strive to be better. So that's cool that we have some big brained cats and dragons here. I'm guessing the kind big brained math person is the person chatting above you, but if not, that's cool. We are big brained in our own way.
So we need to make sure that the weight matrix is of an appropriate size, that the inputs to it, the mean of the inputs basically is not going to change. So
mean of the inputs should not change because it's of a size. How does that work?
Turns out that if you use normally distributed random numbers and divide it by the number of rows in the weight matrix, it turns out that particular random initialization keeps your numbers at about the right scale, right?
So this divide helps. Okay. Maybe it was you. You don't know. Sometimes you do kind things, but you don't consider them. Maybe you said something and that triggered an understanding. And I don't want to call it cartoon. That triggers an understanding of a problem to another person. It's a really cool series. And I suppose it actually ended. Like it was, yeah, see, it actually ended. It was 2 seasons. So, yeah, I do recommend it. It, like talks about, God, I don't want to spoil anything. Anyway, it talks about, virtual things. Virtual beings. Started off, I watch anything that has a character that's a programmer. So that's what it drew me in. The girl and the boy are programmers. Her dad is like a really famous, engineer. So yeah, highly recommend it. Yes, when it ended, I just sat there for 5 minutes. I was like, wow. It was really cool.
So this idea that if you've done linear algebra, basically if the eigenvalue, the first eigenvalue is like bigger than 1 or smaller than 1, it's going to cause the gradients to get bigger and bigger, or smaller and smaller. That's called gradient explosion, right? So we'll talk more about this in the deep learning course, but if you're interested, you can look up Chi-Ming-He initialization and read all about this concept, right? But
no, I'm good.
But for now, it's probably just enough to know that if you use this type of random number generation, you're going to get random numbers that are nicely behaved. You're going to start
nicely behaved random numbers. Not as much gambling as, as one would think.
Out with an input, which is mean 0, standard deviation 1. Once you put it through this set of random numbers, you'll still have something that's about mean 0, standard deviation 1. That's basically the goal. Okay?
Okay.
One nice thing about PyTorch is that you can play with this stuff, right? So torch.randn, try it out. Every time you see a function being used, run it, right? And take a look. And so you'll see it looks a lot like NumPy, right? But it doesn't return a NumPy array. It returns a tensor.
I was about to say matrix, but sure, tensor. Yep.
And in fact, now I'm GPU programming. Okay?
Yes, if you say CUDA, it uses GPU instead of CPU.
Put .CUDA, and now it's doing it on the GPU. So,
I really should let Jeremy Howard talk. I'm not the expert here.
I just multiplied that matrix by 3 very quickly on the GPU, right? So that's how we do GPU programming with PyTorch, right? So this is our weight matrix. So we create, as I said, one 28 by 28 by 10. One is just rank 1 of 10 for the biases. We have to make them a parameter. This is basically telling PyTorch which things to update when it does SGD. That's
okay. This NN is from our model, right? We had NN model, and now we're updating the parameters, starting off randomly. Okay, I'm actually understanding what's happening.
It's very minor technical detail. So having created the weight matrices, we then define a special method with the name forward. This is a special method. The name forward has a special meaning in PyTorch. A method called
not backpropagation. Just, feed forward is a thing. Learned from school. You have much... Oh. Oh God, you think? I have a nicer voice to listen to? Okay, that's giving me permission to talk more. Thank you. Yeah, I don't dislike my voice. I used to record my voice a lot, and it was cool. I started off disliking it, and then I learned to like it. When we grow older, we learn to love ourselves more.
Forward in PyTorch is the name of the method that will get called when your layer is calculated. Okay, so if you create a neural net or a layer, you have to define forward. And it's going to get passed the data from the previous layer. So our definition is to do a matrix.
So we have our A, we have our X, and we have our B, and our algorithm is AX plus B, and we want the Y, which is a prediction. That's I'd say high school-ish math, because I remember sync.
Matrix multiplication of.
I don't know what you guys study in your high schools, though. That's what it means. Yep, run stuff through from input and return output. Yeah. Yes, I am the same. I so cringe. I've been hearing my voice, but I don't hate it anymore. Yeah. Especially when you have to edit your own voice, and God, when you get to hear your speech patterns, that is with all the ums and the ahs and the weird things that you notice. It's quite funny. I'm looking forward to hearing Doo's voice. Now I'm my expectations are raised. I don't want to be mean. I hate expectations.
And
Plus
add on the biases.
RB, yep.
So that's it.
But yeah, that's it. But it's matrix. It's not just one, one X and one A and one B. It's a tensor load of them.
That's what happened earlier on when we said nn.linear. It created this thing for us.
Kindness all around. I am lovely. But people can also be nice. Let's start off, nice, and if they're mean, great, sure, I'll get away from them. But let's start off nice. I was criticized very recently on being too nice. I mean, I don't mean it that way, but being nice towards strangers in that way.
Okay.
And also, I'm not a baby.
They spell reshape, they spell it view. Okay.
They spell reshape as view. That's a very odd way of spelling. It's like my level of spelling, because I make a lot of spelling mistakes.
So view means reshape. So you can see here we end up with something where the number of images we're going to leave the same, and then we're going to replace row by...
Yes, -1 means go down one, if you're 3D, go down to 2D, like that. Go down one shape.
Column with a single axis, again, -1 meaning as long as required. Okay, so this is how we flatten something.
Oh, okay.
Using PyTorch. So we flatten it, do a matrix multiply, and then finally we do a softmax. So softmax is the activation function we use. If you look in...
That one I don't know, so I'm going to try to listen with focus.
In the deep learning repo, you'll find something called entropy example, where you'll see an example of softmax. But a softmax simply takes the outputs from our final layer. So we get our outputs from our linear layer, and what we do is we go e to the power of for each, and then we take that number and we divide by the sum of the e to the power ofs. That's called softmax.
Okay.
Why do we do that?
Whoa! Did not expect him to answer that.
Well, because we're dividing this by the sum that means that the sum of those itself must add to 1, right? And that's what we want. We want the probabilities of all the possible outcomes add to 1.
Okay, but why do we do the e to the power of?
Furthermore, because we're using e to the power of, that means we know that every one of these is between 0 and 1, and probability.
Okay, it's like log, but not. Isn't e the power of the opposite of log? I have forgotten a lot of stuff.
These we know should be between 0 and 1.
Okay, so between 0 and 1 is our intention, and summing it to 1, that's why we're doing the divide. Okay, that makes sense.
And then finally, because we're using e to the power of, it tends to mean that slightly bigger values in the input turn into much bigger values in the output. So you'll see, generally speaking, in my softmax, there was going to be one big number and lots of small numbers. And that's what we want, right? Because we know that the output is one hot encoded. So in other words, a softmax activation function, the softmax nonlinearity, is something that returns things that behave like probabilities, and where one of those probabilities is more likely to be kind of high and the other ones are more likely to be low. And we know that's what we want for to map to our one hot encoding. So a softmax is a great...
It's always positive. We might have negative values. That's really... Thank you, Mustafa. That's a good point.
Help the neural net. Make it easier for the neural net to map to the output that you wanted.
Okay.
And this is what we generally want. When we're kind of designing neural networks, we try to come up with little architectural tweaks that make it as easy for it as possible to match the output that we know we want. So that's basically it, right? Like, rather than doing sequential, and using nn.linear, nn.softmax, we've defined it from scratch. We can now say, just like before, our net is equal to that class.CUDA, and we can say .fit, and we get to within a slight random deviation, exactly the same output. Okay?
I think there's an ad break in Twitch. Sorry about that. I tried to snooze it multiple times, and it was still there. So, if you are getting an ad, sorry.
So, what I'd like you to do during the week is to play around with, like, torch.randn to generate some random tensors, torch.matmul to start multiplying them together, adding them up. Try to make sure that you can rewrite softmax yourself from scratch. Try to fiddle around a bit with, reshaping view, all that kind of stuff, so that by the time you...
This says dimension equals 0. What does that mean exactly? Does it mean it's just 1? We have 1... Okay.
Come back next week, you feel like pretty comfortable with PyTorch. And if you Google for PyTorch tutorial, you'll see there's a lot of great material actually on the PyTorch website to help you along, basically showing you how to create tensors and modify them and do operations on them. All right, great. Yes.
Oh, that's so cute. Another cool property of e to the power of x, it never equals 0. So we can divide over... Oh my god, that's so cool. Without considering the case where it equals 0. If so, the division would be undefined. Yes. Yes, so we can not worry about dividing. That's cool. Oh. And would say the dimension equals 0, I would say summing over the first dimension of the first dimension of our matrix, or I think it's just one dimension because like we flattened it, I think. And my brain is like, the video's ending in 2 minutes, I'm gonna go. Let's not think anymore.
You had a question? Can you pass it over?
So I see that the forward is the layer that gets applied after each of the linear layers. So,
well, not quite. The forward is just the definition of the module. So this is like how we're implementing linear.
So does that mean after each linear layer we have to apply the same function? Let's say we can't do a log softmax after layer 1 and then apply some other function after layer 2 if we have like a multi-layer neural network.
So normally we define neural networks
That's a cool question. No worries. You forgot the shape of the tensor.
Normally we define neural networks like so. We just say, here is a list of the layers we want. Right? You don't have to write it all by hand ourselves. Right? So you can write as many layers as you like in any order you like here. The point was that here we're not using any of that. We've written our own
from scratch
matmul plus bias, our own softmax.
Whoa.
So this is just Python code. You can write whatever Python code inside forward that you like to define your own neural net. So like you won't normally do this yourself.
Yes, my brain is expanding. I will take over this world. Like, I'm currently happy that I understand what softmax is, because literally everyone is using it. Will I forget it soon? I hope not. Let's pray. This is our 90%, our prediction. And one of them should be the error rate.
Normally you'll just use the layers that PyTorch provides and you'll use .sequential to put them together, or even more likely, you'll download a predefined architecture and use that. We're just doing this to learn how it works behind the scenes.
Yes, and done.
All right, great. Thanks, everybody.
Thank you. We did it. Phew. If anyone's interested in going through this themselves, I'll put the link in the chat. This is fast.ai, ML, Introduction to Machine Learning for Coders. And here you go. Oh, yes. Okay, I sent it. Oh God, I had hidden myself and now I'm back. What's up? So, today was fun. I always love making new friends. About reaching a goal means you have to make a new one. And I don't always, Okay. I really, really, really appreciate you being here on the YouTube side or on the Twitch side. Today was extremely fun. My brain expanded, so that's more cool. I will be looking forward to seeing you guys' streams, so that my brain expands, not just in one direction, but like it's not we have the depth and the breadth. It should be both. Okay, I appreciate you giving me your time and your energy by talking to me. I will I will do my best to learn better, but also looking forward to meeting you and hearing your lovely voices. That sounds creepy, but in a nice way, in a sweet way. Okay, I normally end the streams by doing a countdown so that people and there's probably a lag of my stream, so I am going to end the stream. And thank you again, always, honestly, really thankful that anyone cares, to tune in here. Thank you. And I'm going to end the stream, and I'm going to start with 10. In case anyone has questions. In 10, 9, 8, 7, 6, 5. Don't worry, nothing's going to explode. Yes, I'm from the Middle East. Dark joke. 5. Were we? 5, 4, 3, 2,